Hi, my name is William Jensen, and this is my code walkthrough for PA1 Part A. So we're going to start here in this main class. It's going to be responsible for creating our different thread objects and then launching those threads. It's going to create the kill thread, file thread, and coordinator thread. And then it's also going to pass any shared resources to those thread objects at construction. So all of the threads we're going to use will utilize this kill flag research from the kill thread. This will allow us to signal each of the thread when it's time to end. If we go to this definition here, we can see it's really just a promise and future combined. And we're going to use this, rather than accessing this future data, we'll just be accessing the status of that future data. So that status will indicate whether or not the thread should end. Once it's set to ready, all the threads will end. We can broadcast that state, and we'll trigger it by just calling set value on this promise. The other data that gets passed into the file thread and coordinator thread is this file buffer, which is a shared status of the file threads buffer. And that's just going to be a status parameter combined with a mutex and condition variable used to maintain synchronous access to the status and the buffer. So let's start off with the file thread. Our file thread uses this it encapsulates the creation of the thread into this launch function. So we can just call launch from the main thread. The thread of execution itself is just going to be pretty simple. The file thread's main purpose is to just continuously fill its own buffer, loading in data from the 23 headerless WAV files. And so it's just going to continuously check the status. So it's going to open up a mutex lock and just wait until it's available. And when it's available, we're going to check the status and see if it's empty. If it's empty, we know, oh, okay, we can go ahead and start filling. So we load the file in and then load it to the load the file into the buffer, and then we can update the status to ready and signal our condition variable that we've now updated the status. And this is how we'll kind of communicate over to the coordinator thread that we have data that is ready to be copied over to the coordinator thread, and so we can empty up this file thread buffer and start filling it again. We also have this sleep for 200 milliseconds at the end here. This is just to prevent constantly locking this mutex. This could be done with a, I just added the 200 milliseconds here to the wait for. I like having this kill check be consistent across all the different classes, always having wait for 0 seconds and then being explicit about how long we're pausing in the thread by using the sleep. And if you'll notice, we're just using a unique lock on a mutex here. We're not actually using the condition variable here. And that's because we don't mind waiting for access to that shared status. There isn't any other work the file thread is doing in the meantime. It's just waiting for that status, waiting for that empty state, and then filling. So we can now look over at the coordinator thread. The coordinator thread has a bit more work to do. It kind of has two main jobs, which is filling its buffers. It has a buffer and a B buffer. And it's going to fill that using data stored in the file threads buffer. And then its other job is to push chunks of data that it has, and that'll be to the wave buffers. That's going to push chunks of data, freeing up its own buffers so it could then go ahead and start filling them again from using the data loaded in from the file thread. Let's see okay. Yeah, so at the start of each of our threads, we're initiating this kill event setup, which is just defining that thread count so we can kind of keep track of all of our different threads and know when they have all finished. And then we have our kill event check at the very end here, and that's just going to call this kill check function, which we saw before, which is just waiting on that future status to be ready. When it is ready, we're going to exit this thread. So the main body of the loop, I guess before we get to that, we're enqueuing our A buffer, or pushing our A buffer and B buffer into the empty buffers queue. Yeah, here we have an empty buffers, ready buffers queue, and then a active buffer. And this is used to kind of keep track of the different buffers and their states, and separate the structure in which we have initialized our buffers from the actual logic of emptying, loading, playing, and pushing chunks. And this makes it really easy where if we want to instead of having an A and a B buffer, also have a C buffer, or have an array of 20 buffers, and we would just push all of those buffers we've initialized into our empty buffers at the very start of our thread here. So in this main loop of the thread, we have our push chunk, where if we have any ready buffers, if any of our buffers are filled, we're going to go ahead and we are going to try to push that on over. This is all just kind of temporary stand-ins, since we don't have any of the wave thread playback threads set up in the PA1 part A. So we're just kind of gonna simulate some way of emptying out the buffers. If we can't push chunks off of our two A and B buffers, then we'll have everything kind of freeze up, because the coordinator thread will only have two buffers. It won't be able to empty the file thread buffer. If the file thread buffer can't be emptied, it can't continue loading files. So we're just going to simulate that here. So if the active buffer is not set, and we have ready buffers, we're going to take one of those ready buffers, move it to an active buffer, and this sleep for 3 seconds is just going to be simulating work to move chunks over. And then next time we come around, if we have an active buffer, we're going to sleep again, simulating work, and then push that active buffer into an empty buffer and set that active buffer point to null. So now we have empty buffers that are ready again, and then the data in the file thread can be moved over there. And then the other main functionality is to fill its buffers and empty the file thread buffer. So we're going to make sure that we have empty buffers ready to fill. We're going to update the status to transfer here. Take one of our empty buffers, open it, and then use the file thread copy buffer to target, pass that buffer on over, and the file thread buffer will be copied into this open buffer. Once we have that, we're going to push it into our ready buffer queue, so we can start pushing those chunks, and we're going to update that status to empty. This will free up the file thread, which can then go ahead and start filling its buffer again. Let's see. I think that just about covers all the main functionality for PA1A. Yeah, thank you very much.